All right, so remember what we want to do every time that we are provided with given information that has a congruency in it. You need to put that in your picture. So we've got AC is congruent to BD. Okay, so AC is congruent to BD. Right? And it also says that AC is what to BD? What do those lines mean? Parallel. So go ahead and draw that in as well. Remember, parallel, we use those little arrows to show that the segments are parallel. All right. So they give us one explicit congruency, right? And it's sides. Now we need to come up with two more. So we either need to come up with angles that are congruent and another side that's congruent, or two sets of sides that are congruent. All right. So try to walk our way through doing this. One thing I want you guys to realize and kind of understand that, and it happens with other vocabulary words, but parallel is a vocabulary word, right? But parallel only tells us that two lines will never intersect. So it doesn't provide us any congruencies. But we had an entire chapter dedicated to parallel lines, right? And congruencies that come with parallel lines, right? So even though it's a vocabulary word, parallel is a vocabulary word, we're going to look and we're going to try to find some congruencies based off of it. But our reason will not be because of the definition of parallel lines. Our reason will be because alternate interior angles are congruent, or alternate exterior angles are congruent, or same side interior angles are supplementary, or something like that. Does that make sense?
Yeah.
So that's one of the times that the definition of the vocabulary word isn't your reason. It's a theorem or a postulate that deals with that definition. Okay. So when we look at AC being parallel to BD, that is a vocab word. And we want to think about all the topics that could come to mind or should come to mind when we see that segment there parallel to that one. Okay? When we deal with parallel lines, I like to, especially when you have a polygon, like this white shape over here, it's quadrilateral, I like to look at initially the transversals that kind of travel through the inside of that figure. Okay, that is a transversal. But A, B, and C, D, those segments are also transversals, right? Okay, but that one usually will provide congruencies better than the other two will. Okay, A, B, and C, D. If we look at those transversals, they produce same side interior angles, and this one produces what types of angles? If I look at this angle here and that angle there, what type of angles are those? Alternate interior. So, what should we know about those alternate interior angles if those lines initially were parallel? Congruent, okay? So now, can I call it angle C and angle B?
No.
Why not?
And there's two of them.
Okay, there's more than one angle with vertex C, right? Okay, so what we want to do is we want to trace out that purple angle. So I'm going to go from A to C and then finish back up at B, right? Does that kind of make sense? And then I'll trace that at angle. So I'm going to say angle A, C, B. Okay, now 3 letters to name this angle over here.
CBC.
CBD is fine. Okay, if you named it DBC, that is fine as well. When we're naming angles, the first and last letter can flip-flop, but the vertex always has to be in the middle. All right. Now, our reason for this, I know it's kind of a pain in the butt to write this, but this is kind of what we want to do. If two parallel lines are intersected by a transversal, then alternate interior angles are congruent. Okay? It's a lot to write, correct? Now, if you remember back to earlier in chapter 3, that statement was called the alternate interior angles theorem. If you want to use that, I don't have a big problem with it. But here's what you got to pay attention to. It might be the alternate interior angles theorem in this textbook, but in other textbooks, it might not have a name. In other textbooks, it might actually be the converse of the alternate interior angles theorem. Okay? So it's got different names per textbook that you look at. Think about the end of course exam. It's not written to a textbook. Does that make sense? Okay? So if you write alternate interior angles theorem, the author of that test, or the person that's grading that test, or the algorithm behind the scenes that's reading your work and saying, yeah, they've done enough here to show that they know what they're talking about or not, I don't know if that's going to give you credit. That will give you credit. The way we wrote it up there on the board, that will give you credit. Does that make sense?
Yeah.
All right. So on those tests, you don't want to leave it up to the interpretation of the person that's grading it or the machine that's grading it. You want to make sure that you are specific, leaving out all possibilities of ambiguous answers. Okay. Ambiguous meaning it can be interpreted in multiple ways, right?
Yep.
So make sure you clarify your thoughts and make sure that there's no, it could be this, could be that kind of thing, because they're always going to guess wrong. Does that make sense? Okay. So as we go through, I don't like writing that, and I assume that you probably don't either. So I will use alternate interior angles theorem, okay? Or I'll say alternate interior angles are congruent. But when you get to the test, remind yourself of how that's being graded, and that you need to be very specific in the way you type things out. Okay. On those tests, a lot of the questions are not like drop-down windows or anything like that. They're, write out in, like they'll give you maybe 2 columns. You write out your reasons and statements. You type them out. Maybe it's paragraph form. We'll take a couple of these in the next couple of days, maybe, and write them in paragraph form. Okay. So just keep that in mind as we're going through stuff. But that became a congruency, right? We have now come up with another congruency that we need to fill into our picture. Okay, so.
Bless you. You're welcome. I say thank you. I know. I said it for you.
All right, so we got those 2 angles congruent, right? So now, if we look at the top triangle, we've got a side and an angle. If we look at the bottom triangle, we've got a side and an angle, right?
Yep.
So hopefully we realize that this is probably going to set itself up best to use side, angle, side, and not side, side, side. Okay? What side could we look at that would be important here or useful? CB, okay? And what are you going to say about CB? Good. So CB is congruent to itself. That's the reflexive property. And draw that in. Okay.
Does it matter if we were to put those in a different order?
No, if you want to call it CB is congruent to BC, or if you said BC is congruent to BC, that's fine. Okay. Or you say steps 2 and 3? Yeah, that's fine as well. Okay. Step 2 and step 3 could be flip-flopped. Okay. Because step 3 does not depend on statement 1 or statement 2. And statement 2 only depends on the part of the given that says parallel lines. So as long as step 2 comes after you said that AC and BD are parallel, it can come anywhere. Okay. So that's actually a really good question. Once we have that, though, do we have 3 parts up top?
Yeah.
Yeah, and they're in the order of you've got a side here, you've got an angle right there, and you come back to a side, right? And the angle is sandwiched between 2 sides. So that is a good order that we're looking for, okay? Because that's one of our theorems, our postulates. Over here in the other triangle, we have to have the same order. You have to have an angle sandwiched between the 2 sides that you're referring to or you're interested in. And we do have this angle here sandwiched between those 2 sides, right? So we got side, angle, side in both triangles. So let's say that the triangles are congruent. So we'll say triangle, call it whatever you want. Let's call the top one. What do we call the top one? ABC is perfectly fine. Okay. And then if I name the top one triangle ABC, following that same exact pattern,
DBC.
DBC?
Yeah.
Nope. Because we went from A, listen, we went from A down to B, right? And there was no markings in that line. Yeah, so we got to start at D and go down to C. Okay, because I went down a segment that had no markings. So I could either start at C and go to D or D and go to C, right? Yeah. But it makes sense to go from D to C because as I was naming the first triangle, when I went from B to C, I traveled down 2 markings, right? Mm-hmm. So when I name the second triangle, my second path has to be down the same segment that has 2 markings in it. So I got to start at D, go to C, and then finish at B. So D, C, B. And that reason, like I said yesterday, whenever you say triangles are congruent, you're always going to have a 3-letter reason. Right now, okay, you'll have 3 letters or less. Okay, there will be one theorem that has 2 letters, the hypotenuse leg. That's what we're looking at there. Okay, now, the reason we had to name those correctly is because now once I've shown triangles congruent, I want to look at and see if that statement form matches what we wanted to prove. When I say matches, they have to be 100% identical. Okay? Are they?
No.
No. Okay? But the reason we had to name these correctly is because now I should be able to locate those 2 things, C, D, and A, B. So there's C and D, right? First 2 letters.
Yeah.
Our A and B are the first 2 letters over there. Mm-hmm. Okay, so because they're the first 2 letters in both names, that meant they were what? They will be congruent, but just because named off of, or the relation based off of being matching parts here, matching names, aren't they corresponding? Yeah. Okay, so the corresponding part is what I was looking for there. So they're corresponding parts. They come from congruent triangles, right? So then they're congruent, right? So AB is congruent to CD. Right. And you guys are saying CP, CTC. And that's what I was trying to walk you through, because they're corresponding parts. They're the first 2 letters in the first name, the first 2 letters in the second name. So that means they're corresponding. Okay, they match. And then they're segments, so that means they're parts of the triangles. They came from congruent triangles. So those corresponding parts that come from congruent triangles are also congruent. And that's what CP, CTC stands for. Okay. Is that doable?
Yeah.
All right, now, I didn't write this, just like that, right? Okay, I wrote AB first, but we know we can use the symmetric property to flip that and still get the same remarks, right? Same result. Kind of going off of the idea earlier that we could have flipped that one and that one. Okay, they could have came in any order in between steps 1, 2, and 3. Okay. Step 2 has to come after this, okay? But it could be step 3, and step 3 could have switched spots, right? Step 4, though, step 4 can't come up here and be step 2, right? Because triangle congruencies is dependent on first having those sides and angles congruent. And you don't know that. If you were to put step 4 right here, you don't know that you have those parts congruent yet, right? So this thing here, this step 4, is dependent on having that, and that determined first before you can say that the triangles are congruent. Okay? In the past, I'd get people that would do a proof, and they'd have all the information that they needed, or that they thought they needed, but their order was it's like they took a handful of statements and just threw them at the board, and wherever they stuck, and that they thought they proved. Okay? There's a particular order that has to be followed. All right. It's all about dependency and independent statements, and understanding the difference between those things. Okay. Remember, independent means it can stand alone. It doesn't get impacted by something else. Dependent means it relies on something else, right? Okay. So statement 4 relies on these 3 things, these 3 congruencies above it. So it has to come after them. Let's do this one. All right, so this is similar to one that we saw yesterday. Okay, using different letters, using ultimately different angles, and different names for those angles, but it's a very similar question that we saw yesterday. Okay? So I want you guys to write your given down, and then I want you to write the first statement that you get in addition to that given. Okay? So there's an implied congruency existing inside your given information. I want you to write that down. Here, you got it? Fantastic. You know why you got that? Great teaching.
Of course you got it. Why is your hair? Why is your?
No, those two can be.
Okay, I was thinking your hair is like.
Because the
Look how stupid you are.
right and the midpoints provide those congruencies. Right, the midpoint doesn't impact the angle also.
I think 70 last week, my shirt.
Gumby. There's no Gumby.
Oh, Gumby is.
I used to watch Gumby. Like software.
All right, so our given C is midpoint of AE and BD, right? So that's given. Now, if that's given, good. Okay, we're saying that that segment and that segment are congruent, right? C is the midpoint of BD, so we can say BC is congruent to CE. Okay. Now you can flip-flop those names, right? You can call it CB, you can call it DC. You can say BC is congruent to DC. You can say CB is congruent to CD, whatever. Okay. I like to name it this way because I see the C in the middle, right? So it reminds me that through that work that C was the midpoint. You don't have to do it that way, but it is useful.
We got AC equals CE.
Yep. AC is also congruent to CE. Okay. Then my picture in your saying definition. Right now, that is ultimate, unless it's the reflexive property, that is the easiest way for us to show segments congruent. Reflexive property is the easiest way to show segments congruent, right? Midpoint is the next easiest way to show segments congruent. The third way that we can show segments congruent is actually a very difficult process. It involves the segment addition postulate and addition properties of equality and stuff like that. We will have to do that at some point. But the only way right now that we want to show segments congruent, or that we have the ability to show segments congruent, is either through the reflexive property or through the use of the midpoint. Okay, or a bisector or something like that, but a bisector leads us to a midpoint. So as you're going through these questions, you think, okay, I want to show, I've got two sides congruent to two sides, and you're thinking, well, side could be an option here. Well, I have to look at that side there and that side there, right? Those are the third sides. If that's going to be an option, if that's the route I want to go, then I have to have a midpoint for those two things. They have to share the same midpoint, or I can see if they're reflexive and they're the same segment in both pictures. And that's not existing there, right? So it's impossible for us to show those additional sides here. So side is not going to work here. So if side is not going to work, what will work?
Side angle side.
Side angle side will work. So what's the angle then? Okay, be careful on BCA congruent to, I'd go BCI, I'd go DCE. But again, if you named it ECD, that'd be fine as well. So that's what is the reason for that? Vertical angles are congruent. It was a theorem that we had. Okay, a lot of people will say, I get this wrong, and usually I give them credit for it, and I just tell them to be careful. But a lot of people say definition of vertical angles. If you were to look up in the back of the book, the definition of vertical angles, it says nothing about congruency. Vertical angles theorem, it says vertical, basically says vertical angles are congruent. That's what the theorem says. All right, so draw that picture in, or that congruency in our picture. So now we have three parts. In what order are they in? SAS. Okay. Just before we go on any further, did this phrase here depend or get impacted by that one?
No.
Or vice versa?
No.
No. So they could have been flip-flop. Okay. But one thing that we need to make sure of is that this statement here, statement 2, is dependent on that, right? Okay. So as you're doing your homework, you might every once in a while they might have like a given as like a third or fourth step. Okay. And they start off with maybe they start off with another piece of given, or maybe they start off with information from your picture. You could actually, if you wanted to, I don't know if anybody would do this, but that statement about vertical angles could actually came first, okay? Because none of the given impacts the fact that they're vertical, right? Okay. So sometimes in your homework, the author will do that. You just have to realize that these things here, statement number 2, is dependent on midpoint. So the only time I can say statement 2 is after I've written something about a midpoint. Okay? And then it can come anywhere after that. Now that we've got those 3 parts, you can say that the triangles are congruent, right? Now this is the reason why I like to name the angles in the order that I did. Because if I name these angles here in step 3 using the same pathway, the same process, then I can just basically cut and paste what I've written there and what I've written there. But instead of putting the angle symbol out front, I put triangle symbol out. And if I trace over BCA, triangle BCA, I'll look at that one, and then I go to DCE, triangle DCE, they are the exact same order, they're the exact same triangle, and now I've got matching parts. So we can use the CPCTC thing if we need to. So that, what was the reason there? SA. Side angle side. Once you have the triangles congruent, take that statement, match it back up to that, and see if they're the same. If they're the same, you're done. If they're not, you have a CPCTC statement to come next. Okay? And if I look at angle 1 and angle 2, okay? Look at angle 1 and angle 2. Can we say that they are congruent? And actually, no, we cannot, because they're not matching parts, right? See how this one here, that one there is between no markings and 2 markings. This one here is between 1 marking and 0 markings. So they're not corresponding angles. Okay? So this is my fault. That 2 should not be there. That 2 should actually be, kind of erase it and put that 2 up there. Because now 1 and 2 are matching parts. Okay? So then we can say in step 5, angle 1 is near angle 2 by CPCTC. Okay? I apologize for that. We could end up showing that leaving 1 and 2 where they were. If I knew a little bit more about these segments of this triangle, maybe we could eventually say that 1 and 2, where 2 was down here at the bottom, would be congruent. If I knew all 4 of these red segments were the same length, we could do that. Okay? But that's another section out of this chapter later on, isosceles triangles. Is that something you do?
Yep.
All right, so I apologize for that
Yeah.
typo error.
Let's not do that one.
Let's do this one because I don't understand it.
Yeah.
This one's a little bit hard. Why? We want to do things that are easy, right?
Yeah.
I need to challenge yourself.
Right, you don't grow. I mean, everything's always easy,
It's
right?
Friday. It's not time to challenge.
It's Friday.
Challenge
So at the end of something, you quit, right?
Yeah.
So at the end of a concert, you stop playing your tuba or whatever.
Yeah, I do that even too. That's gonna take 30 minutes.
No, it's not.
Yeah, you say that now, so you can.
All right, we'll do this. This is the last one we do. How's that?
All right, then.
Yeah, angle 1 and angle 2. What? That's a 3. That's 4. 2. So when we look at this, here's the thing we got to pay attention to. That angle and that angle, that's angle 1. Okay? This is angle 2. Okay, so they are not on the inside of the triangles, right? It would be a lot easier if they were on the inside of the triangles, correct? Okay. If they're on the outside, that becomes a problem, okay? We have AB congruent to AC, right? That's pretty easy. All right, that's an explicit congruency that they provide us with, so draw that in. All right, let's talk about angle 1 and how it relates to an angle that's on the inside of the triangle. What angle is on the inside of the triangle angle 1 would relate to? It would relate to 3, right? What do you know about angle 1 and angle 3? Okay. Let's use it. Let's say they equal 1. Let's just use the word supplementary because we can use a theorem then that we've already talked about that makes things easy. So let's say angle 1 and angle 3 are supplementary. Because they form a what? A straight line, and that's a linear pair. Okay, so we have a linear pair postulate that states if two angles form a linear pair, then they are supplementary. Okay? So if I say that about angle 1 and angle 3, what can I say about 1? Okay, so angle 2 and angle 4 are also supplementary. All right, so you guys want to go the long way or want to go the short way?
Short way.
Short way takes more thought.
Okay, I'm ready.
So you want to go the long way?
Yeah.
Let's go the long way.
Oh,
Let's do it the long way, and then I'll show you
Never mind, we're doing the long way. I don't even want to know.
having the nice aspect of theorems. Okay, because the long way is like 2 or 3 more steps. Okay, so what if they're supplementary? Because this is the logical progression that most people would go through. Because we've seen it before. If they're supplementary, what do you know about them?
Angle 1 and angle 3 equals angle 2 and angle 4.
Okay, be more right. What you said is fine, but you did like 2 or 3 steps all wrapped up into one. So be more explicit, more expressive with what you're writing. So I'm going to say measure of angle 1 plus measure of angle 3 equals 180. And we're going to say measure of angle 2 plus measure of angle 4 equals 180. Okay, so that's going to be, you guys know that's the definition of what?
Linear supplementary.
Supplementary angle. Okay. Now, that's going to say, because they both equal 180, we can say angle 1 plus angle 2 is equal to, oh, sorry, it's 3, yes.
And then it's equal to
3 is equal to 2 plus 4. And that's substitution, right?
yeah.
All right, so hopefully you guys see it. This is starting to mimic some other proofs that we've done earlier in the year, right? Now, when we get to this stage on other proofs throughout the year, we like to recognize that there was something on both sides, right?
Yeah.
Is there something that is on both sides that's equal?
Yeah.
What?
3, 4.
Not one, not right here, right here.
No.
Now, visually, using the labels that we've used, 1 is not on both sides, 3 is not on both sides, 2 is not on both sides, 4 is not on both sides, right? But numerically, 1 and 2 are the same, right? Okay. Now, in the past, we said, measure. I'm going to write this down just kind of as a clerical or technical, procedural type thing. Let's say measure angle 1 is equal to measure angle 2. That's the definition of congruency, going from a shape to a measurement, right? Okay. So now I can remove those from both sides. Okay, we can remove that from both sides. We can remove 1 there, and we remove 2 from there. So what's that leave you with?
Measure of angle 3 equals measure of angle 4.
3 is equal to 4. Okay, so that is just subtraction, right? That's what we did. We removed those 2 things. So subtraction. And now I'm going to go back from that, because those are numbers. Okay, so it might be like 30 degrees equals 30 degrees, or 24 degrees equals 24 degrees, whatever the range for word. So I'm going to go back to shapes. And say shape angle 3 and shape of angle 4 are congruent. And that's the definition of congruency. What's nice about that is that 3 and 4 were where in the picture? They were inside. They were parts of the triangle. So now we'll come back here. We knew that. We knew that. Now we've gained those two angles, 3 and 4, to be congruent. Okay? But here's the purpose of having additional theorems and remembering additional theorems. Because that information, right there, okay, is all encapsulated in another theorem that says if two angles are congruent to the same angle or two congruent angles, okay, then, sorry, let me start over. I think I forgot the words up there. If two angles, okay, so let's say the two angles are 3 and 4, okay, if two angles, in our case 3 and 4, are supplementary to the same angle or two congruent angles, are those two angles congruent?
Yeah.
Then angles 3 and 4 are congruent. Okay? If you remember back, I forget what section it was, but that's called the congruent supplements theorem. Okay? If you have two angles that are supplementary to the same angle or to two congruent angles, then the two angles you started with are actually congruent to one another. And that would take steps 3, 4, 5, 6, and 7 and put them in one statement, number 3. And that would make the proof a lot shorter, right? But in order to do that, to take the easy route, we have to have more thought, right? We have to put kind of legwork in remembering what those extra formulas or extra theorems state for us. Okay? Now, if I look at my pictures, we've done the hard part of this question. I need one more congruency. What's the congruency? AD. Good. AD is reflexive, so let's say step 8, AD is congruent to AD. Reflexive property. Going back to our picture. That in. So now those two triangles are congruent, right?
Yeah.
So I'm going to call it, I'm going to go ACD and then ABD. ACD, ACD, congruent to triangle A, let's say DB, BD, ABD. And that is side angle side. And they wanted us to prove not that, but B was the same thing as C. Is angle B corresponding to angle C? Angle C is congruent to angle B. C, B, C, B, C. All right. Now here's the thing. Like I said about theorems, that's 10 steps, right?
Yeah.
And we'll have some that are longer than that at some point. But if we use a theorem prior, that's 5 steps or 4 steps. Okay? So learning your theorems and committing to the memory and being able to pull from them, even though it might have been 4 or 5 weeks since we last seen it, is going to be useful. Okay? So that's a few proofs. If you struggle with these, if you know you're having problems, go back through and watch the videos again. There's nothing wrong with doing the exact same proof over and over and over again. Okay? You will take it from somebody who's been in your seats and that still does proofs for courses that I take. Doing the same thing over and over and over again will be beneficial. Okay? What I would do if I were you is if you're struggling with these, start back from scratch. Okay? So I'd clear it all out, start on a fresh piece of paper with just the given, the proof, and the picture, and see if I can go through the same 10 steps. Okay? And then match up to what I've done in class or what's in the video and see if you did it right. If you can't do it right, start over again and go through those 10 steps from scratch and see if it matches up again. And keep doing that until you're able to consistently get the same results through these proofs. Does that make sense?
Yeah.
Okay. And that people ask, how do I study this stuff? How do I prepare for tests and quizzes? That's how you do it. All right? You have to practice. You have to convince yourself of these properties, these theorems, these definitions, and how they're used. And I think that's a useful procedure to do that. There is